Supermassive black holes are enigmatic cosmic objects with exceptionally strong gravitational forces, which have piqued the interest of scientists and researchers. Their interest in them has endured for a prolonged period. These large structures are located in the middle of galaxies. Different creation methods affect the role the galaxies play in changing over time. Nonetheless, a remarkable observation that was just made contradicts with what we believed before a supermassive black hole accomplished an entire 180-degree turnaround. The universe has had its understanding challenged by this groundbreaking discovery. Black hole turnarounds lead to alterations in qualities and behaviors that were once considered inherent in these celestial objects. This event prompts us to reconsider our understanding of black holes and encourages us to seek further knowledge. The results are considerable, and they might transform our perspective on the world and its elementary regulations. Our detailed investigation will cover how supermassive black holes form and grow, revealing important information about these phenomena. We will also explore the role they play in how galaxies move. Afterward, the topic of a black hole spinning will be addressed. The analysis will concentrate on identifying the factors behind this change and its potential consequences. Our focus will also include the latest findings and the associated exploratory theories. We will also discuss the larger impacts of this innovative occurrence. Understanding how black holes change their direction might offer insights into these enigmatic cosmic entities. It's possible to expand our comprehension of the entire world too. Supermassive black holes are celestial objects with an immense gravitational pull. Galaxies surround their home. These puzzling occurrences possess a mass that is millions to billions of times greater than our Sun. Understanding the composition of galaxies and the universe is essential to comprehend how they have transformed over time. Various methods are employed to form these immense black holes. When massive stars disintegrate or when significant amounts of matter fall into them gradually, it is an example. The formation of galaxies heavily depends on their contributions. How stars and gas move around in their area heavily depends on them. A number of components of supermassive black holes have been studied by scientists. For example, their event horizons, where the gravitational force is so powerful that virtually nothing can break free. By studying their accretion disks, jets, and their interaction with surrounding matter, much can be learned about the movement of energy around these objects. They are surrounded by energy, and observing their movement can teach you a lot. A rare event in the cosmos is the turnaround effect, whereby specific characteristics and behaviors of supermassive black holes alter entirely. There was once a notion that massive black holes incessantly consumed matter and enlarged over time. Recent discoveries have cast doubt on this concept though. A sudden change in either the accretion rate or mass growth processes characterizes the turnaround phenomenon of a supermassive black hole. The result is either significantly slowed down or completely stopped consumption of its materials. The factors that previously stimulated its expansion are now operating to impede it. This is not yet well understood, and researchers are still investigating it. Black hole turnarounds have significant effects. They make us reconsider our present notions and conceptions regarding the ways in which supermassive black holes act and evolve with the passage of time. The event may elucidate the intricate links between a black hole and its nearby surroundings. These interactions are manifested through neighboring matter's availability, gravitational effects, and feedback mechanisms. We have obtained essential knowledge about the conduct of enormous black holes through observations and discoveries made about black hole turnarounds. They have challenged our preconceived notions about them. Advanced telescopes and observation methods have played a vital role in discovering and researching these topics. The discovery of supermassive black holes whose accretion activity has reduced or ceased is considered a significant breakthrough by scientists. A decrease in high-energy radiation emissions is typically observed during the accumulation process. Astronomers use various tools such as X-ray telescopes, radio telescopes, and space-based observatories to track the emission fingerprints of these black holes over time. The research on galactic centers and their immediate surroundings provide vital information about how black holes rotate. The distribution of stars, gas, and dust around a supermassive black hole provides astronomers with information on how it changes or interacts with its surroundings. They can determine their qualities as well. Significant findings have been obtained by monitoring active galactic nuclei, AGNs, with supermassive black holes over a prolonged period. These attempts have shown that some AGNs can lose brightness and become less variable in their light emission. This means that the black hole's matter intake rate has changed. A supermassive black hole causing disturbances among passing stars or gas clouds is additional evidence for the return effect. Tidal disruptions are identifiable by unique indications, which include bright radiation flares. We can use these indications to identify moments when the black hole's accretion activity has significantly altered. The combination of data from various wavelengths can enhance astronomers' knowledge of black hole turnarounds. The wavelengths listed include X-rays, radio waves, and optical views. By looking at these instances through several lenses, they can gain a comprehensive view of their operations. The objectives of scientists is to identify the reasons behind the changes and their implications for the development of supermassive black holes and their residing galaxies. By analyzing these observations carefully, they do this. Black hole rotation is a phenomenon that astrophysicists are striving to provide theoretical reasons for. Supermassive black hole characteristics may change according to various theories that have been proposed. As per one theory, the amount of substance that can plunge into a black hole may shift. This might result in a directional shift. A decrease in growth rate could occur due to changes in gas amounts or flow issues towards the black hole. This might be the cause of the rotation. Several factors could impact this, including close galaxy interactions, mergers, or the depletion of gas reserves. Supermassive black holes' powerful jets and outflows have the ability to change their surroundings. Ejecting fast-moving particles and radiation through feedback processes may allow for a change in the accumulation process. It can make it go in the opposite direction. Changes in the way the accretion disk around the black hole moves or changes in the properties of the material falling into it have been suggested as possible causes. These changes could be a result of the disk experiencing instability or disturbances. This may stop or slow down the flow of accretion. By and large, theoretical models strive to integrate all of these distinct processes in order to clarify how supermassive black holes can alter direction. To better comprehend these complex events, scientists utilize numerical simulations, analytical calculations, and observations. Their investigation into the changes occurring in black hole traits involves understanding the underlying physical processes. We can learn how they impact the growth of galaxies as well. These discoveries have implications that extend beyond astrophysics. The provision of clues regarding basic physics by them helps us unravel more secrets about the cosmos. So, if you found the video informative, then do like, share, and subscribe to the channel.